So in the movie, this is what he says. And it has the definition of a vector in it. He says, he's called vector because I am committing crimes with both direction and magnitude. Oh yeah. Direction and magnitude is what vectors are used for. So we have a vector, it looks like a ray from geometry, except the vector talks about which direction something's traveling and how far it goes. So how can we tell by looking at this picture which direction it's traveling? Got it. There's an arrow, exactly. It tells you it's traveling from P to Q. And then how long it is, well, we would need to find, the length of that somehow, which we'll do in just a moment. There's different ways of writing vectors. Just kind of skimming through what it says here, reading the important pieces. But you can write a vector like this, where it's got the capital P and the Q, and it looks like it has a ray on top, but it's not a ray. It looks like this already, even bigger. You guys have this in your notes. You can look there too. You see it only has that like half arrow thing. I don't know if that part of the arrow is called. Top half. And then just looking at PQ, which letter would be the initial point? The starting point would be the P, and then the Q would be the other one. You're also going to see some notation that looks like this right here. It has those double bars. That is the magnitude. When you go to find magnitude, you'll see these double bars, and that just means the length from P to Q. So magnitude is length. And to find length, we will be using the distance formula, which you have been using in previous courses. So let's go over that right now. The distance formula is the Pythagorean theorem. Ever heard of it? A squared plus B squared equals C squared. You've heard that, yeah? It's just written in a slightly different form because to get the A and the B, you have to figure out the change in the X, that's what. Change in the X's and then the change in the Y. So you have to find that. So the distance formula looks like this. You can just write it, up there somewhere. I didn't have room on this one, but I know you guys do have it. It's like a square root. And then we do x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That's the distance formula. And we're going to use that anytime that they say find the magnitude, we'll be using the distance formula. Another way of writing vectors would be in bold-faced letters. So like right here, vector P, I don't know why I even does that. Vector P is the same thing as that vector P to Q. It's just written a different way, so they'll also write it that way where it's just dark. So when you're writing it, instead of writing this, you have to go, there's my bold, right? Because you can't do control B. Okay. You know that's a shortcut. Instead of writing, it's just a different way that you're going to see the vectors written. So either one letter that's lowercase and just bold, or you could write it as using the 2 points that make the vector in order from start to finish. So that's just 2 different ways of writing it. All right. So this first example has 2 vectors, and they labeled them boldface U and boldface V. And we have to figure out, or actually they're telling us that it is true, but we just have to show that vector U is equal to vector V. To show that they are equal, we have to show that the direction and the magnitude are the same. So we're going to find the direction and the magnitude. That's the definition of what vectors are, direction and magnitude. So vectors are used, okay, I can't tell you in detail, but I know they're used in plane flying, what's that called? Aviation. Like direction and magnitude, I know it's used there. Okay. figure out direction, we will use slope. Slope tells us the ratio of the rise to the run, and it also tells us if it's going positive or negative. So we know which direction it's going. And then magnitude is the distance formula. And so we will do both of those to show that these two vectors are equal. So we'll start with vector u. So the slope for vector u, do you remember slope formula? I'll write it over here. y2 minus y1 over x2 minus x1. Good. So the slope for u is going to be y2 is 2 minus 0 over 3 minus 0 2/3. And then for v, the slope is going to be y2 is 4 minus 2 over 4 minus 1, 2/3. So there we showed that the slopes are the same, so they have the same direction. And then we need to show that the magnitude is the same. So we'll do the magnitude of u. See, I used my new symbol for magnitude. And the magnitude is just the distance formula, which says subtract x2 minus x1, square it, plus y2 minus y1 squared. But I already actually found x2 minus x1. And I've already found y2 minus y1. Do you see where I've already found x2 minus x1 and y2 minus y1? Do you see where I've already found that for me? When I did the slope, I've already used both of those. So the x2 minus x1 value was what? 3. And then the y2 minus y1 value was 2. So we get square root of 13. And for v, we'll do the magnitude of v. Same thing, we've already done x2 minus x1, which was 3. And then y2 minus y1 is 2. And we get square root of 13. So those are the same. You ready to go on? Turn the page. Awesome. Well, I'm making a video. So if you have something, you can watch the video. I'll figure it out. Did you have a question?
Yeah, but I can probably go get it.
Is it where my 3 and 2 came from?
Yeah.
It was like the formula for slope was x2 minus x1 and y2 minus y1. And the formula for distance formula, which I wrote at the top of the paper, was x2 minus x1 squared plus y2 minus y1 squared. So I just used those values that I found for slope, and I just put them in this spot, so I didn't have to reset that. Just shortcutting it a little bit. All right, on the next page, it talks more about vectors, and if we have a vector that has the initial point at 0, 0, it can be uniquely represented by the coordinates of its terminal point, v1, v2. That's not even that important. The component form is what's important here. Component form of a vector is going to be, it's going to look like this. The vector bold v equals v1 comma v2. So v1 is the horizontal change from the initial point to the terminal point. Horizontally, how does it change? And v2 is the vertical change. So if we have a vector Horizontally, that would be V1. And vertical would be V2. So you see how we're making triangles here. Still, triangles. Okay. They actually call the V1 and V2 the horizontal component and the vertical component. But that's what it means is the change. Here's some formulas for finding the component form and finding the magnitude, which we've actually talked about magnitude already, but I do not like the letters that they used. So we're going to use these formulas and change the letters back to the ones that we are used to using. So instead of the initial point P being at P1, P2, I'm just going to call this X1, Y1. Okay. That's the initial point. And then the terminal point Q, I'm not going to give you new letters. I'm just going to call it X2, Y2. And then to find the component form, we subtract x2 minus x1, comma, y2 minus y1. Okay, don't worry about those p's and q's. That's too confusing. It's just subtract your x's, subtract your y's. But remember back when you do the distance formula or slope, sometimes you can like switch the order and it's okay. It's not okay to switch the order. Because vectors have to do with direction. You have to do the second one minus the first one. You can't switch that order or you're going to get a negative where it should be positive or vice versa. Yes?
Why did they put the two, those twos on the end?
Because the way that they set up their ordered pair was super confusing. Like, don't even look at theirs. I don't like it. Okay, but I will still call that V1, comma V2 because that's the component form where the V1 is the change in the x's and the V2 is the change in the y's, and that's the component form of that vector. So I'll still keep the rest of that. I'm just changing p's and q's to x's and y's so it makes more sense to us and we don't have to like learn new letters. That's just silly. So then the distance formula, I've already given you the distance formula with the x's and y's. Let's use the actual like our distance formula where we do x2 minus x1 and y2 minus y1 instead of the p's and q's that they have. And if you already know the component form, this is what I kind of showed you on the first page. If you already know the component form, if you know the V1, V2 numbers, you have a shortcut for doing your distance formula. You just take that number and square it, and that number, square it, add them together, and square root. So then it's like a squared plus b squared, square root it, and you get your c. So if we know the component form, that's a shortcut. Okay? We will see something in a moment called the unit vector. A unit vector has a, what's this fun little shape mean? Do you remember already? Magnitude, but what's magnitude mean? Length. So a unit vector has a length of 1. Just like a unit circle had a radius of 1, a unit vector has a length of 1. They are related. Okay. Here we have find the component form and the magnitude vector v that has initial point at 4, -7, terminal point at -1, 5. So we've got our initial point and our terminal point. We're finding component form and magnitude. So vector v, component form has chevrons around it, and we subtract our x's, but we always do x2 minus x1, comma, y2 minus y1, close the chevron. And then we simplify that and we get our component form is -5, 12. So that is the component form. Using the formula, that's our V1 and our V2. So from one point to the other, we go left 5 and we go up 12. That's all that means. And then we need to find the magnitude. So we're going to do I don't mean to make that bold, sorry. Magnitude of V. So we'll do the distance formula, but we've already done the subtraction part. So I'm just going to use my V1, V2. I'm going to do negative 5 squared plus 12 squared, and then square root that answer. Gosh, that sounds familiar. Is 5 or 12 possibly ageable? What's the third side? 13. If you don't remember, then do the work, but it is 13. So that would be the magnitude. So that's how long that vector is, 13 units. So the stuff is not difficult. It's just you got to know what the symbols mean and know what they're asking you to do. So use your notes, okay? The work itself is not hard. Definitions of vector addition and scalar multiplication. I would say that these are a lot like when we did matrices. Remember when you add matrices, you just have to add the stuff that's in the same place together. So these are a lot like that, where you're going to add together your x component, your horizontal component, and then you add together your vertical component and put it in the correct spot. So just like we did matrices. Same thing with subtraction. And then scalar multiplication, the same thing when we did matrices. If you were just multiplying a matrix by one number, you just kind of multiply every number inside by that number. It's the same way. So we basically just take that k and multiply it by both pieces of the component form. Okay. That's an easy rule. So if we have these vector operations, we're going to find A, B, and C. A, B, and C are too squished this way for the work I need to do, so I'm going to do like A, B, and C will probably end up way over there. Right there. Okay, just for you organizing your work. And something it doesn't say to do, but it tells you to do in your homework, is we're going to draw a picture also of the vector. And I'm going to use colors so you can see, like, so this vector makes sense to you. So if you're a person that likes to color like I do, I'm going to use like 3 colors. Or a pencil and 3 colors. So we'll start with A. And it says do 2V. So that's a scalar. We're just going to take 2 times the component for negative 2,5 of V. So with a scalar, you just multiply each thing by 2, and we get negative 410. Woo, that's a challenging one, huh? But now we're going to draw it. It does not say the initial point. It just tells us the component. So it's just telling us from the first point to the last point how far this vector is traveling. So my initial point could be arbitrary. It could be anywhere I want to put it. So I'm going to choose to just kind of center it at 0, 0. All right. So I'm going to draw, and I know where the vector is going, so I purposely drew it kind of like not centered. I'm going to draw it, and I'm going to start my initial point for V at 0, 0. So it's my initial point. And it says negative 2,5. Somehow I turned on the wrong thing. Negative 2, I'm sorry, I have to stand like right in front of it while I'm drawing it, or I can't do it. I'll move though. So there's our initial vector, vector V. Now what did we do to vector V? What did we do? Well, that's the final answer. What? We multiplied it by 2. And we know it should be negative 4 of 10, but visually I'm going to show you multiplying by 2 is just adding it with itself. Right? If you have 2 of something, you're just adding it together with another one of itself. So that's what I'm going to do. From here, I'm going to show you the second vector. It's another vector V that starts from the terminal point, and it goes 2 more to the left, 5 more up. From the terminal point. I got to stand in front of it for a second. Sorry. So we did 2V. See my 2 vector V's. And when you do that, you have a length of 2V. And if I actually just started at my terminal, my initial point, and I went to the very end, it would be negative 4 and up 10. So we can confirm that our answer was correct. But The tricky thing is you just have to start the second vector where the first one ends. Okay? So let's do B. B is W minus B. So I don't have to keep scrolling up and down. So W is 3, 4, and we're going to subtract V. So we'll do 3, and then we're going to subtract -2, and then we'll do 4, subtract 5. So I get my new component form, which is 5, -1. I'm going to visualize that for you. This is where I'm going to use 3 colors. Well, I use 3 colors there too. So. Again, using 3 colors. Hey. There we go. So the first thing I did was W. So W was 3, 4. 1, 2, 3 on the X, 1, 2, 3, 4 on the Y. I start at 0, 0 because it doesn't tell you where to start, so I just start wherever I want. It doesn't matter if you start at 0, 0, if you start at 10, 10, or if you start at -2, 5, it doesn't matter. So I'll start at 0, 0. So that's W. And then to the terminal point of W, we're going to take away V. So we're going to do opposite V. Opposite V. So V was -2, 5. So what's the opposite of -2? +2, and isn't that what I did up here? Didn't I add 2? So I'm going to go right 2 on the X. And then I'm going to go, instead of 5, I'm going to go down 5. So we'll go 1, 2, 3, 4, 5. So -V is that vector, where we start at the end of W and we do the opposite of V. From W. And remember, our final answer should be 5, -1. So if I start at my original term, or my original initial point, and I go to my final resting place here, that should be W minus V. That should be that point 5, -1, is it? That's how we visualize these. We add the vectors onto each other. And then the purple one was the answer by itself. Okay, C, V plus 2W. So I'm going to start with V, -2, and I'm going to add on 2 times the X part of the W. And I'm purposely going to write out all this work so that you can see the visual with it. Just if you are somebody who doesn't like to show all the steps, I'm doing it on purpose. And then I'm going to do 5 plus 2 times 4. And then what I would do next is I would do -2 plus 6, and then 5 plus 8, right? And normally I wouldn't even write that step, but I'm going to do it on purpose because we're learning something totally new here. And then we'll combine that and we'll get, I'll put it in green, we'll get 4, 13. So that should be the answer. We're going to visualize it. So I'm going to start at 0, 0, and I'm going to first do V. And V is what? Vector. What is it? V is -2, 5. So I'm going to go to the left 2 and then up 5. Sorry, I have to stand in front of it to do that for, there's V. What do we do to V? We add 2 W's. So from V, I'm going to add on 2 W's. W says 3, 4. So from here, I'm going to go 3, 4 twice. 3 is on the X side though. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Sorry, we're gonna see. So I have W and then W. So I just added on 2W. And for my answer, if I start at 0, 0, where I had started the first one, and I go to the very end, that should be 4, 13 for the X and the Y. So you're finding it algebraically, mathematically, then you're also visualizing these vectors. Okay? What's going to be the hard part though? I know. Okay, the next is a bunch of, wait, what's time is it? Cool. So, I'm going to stop there. You are going to start your assignment. You won't get done with it. You don't know how far you're going to get in your assignment. I think the lunch threw us up a little bit. But you're going to start your assignment, and you're going to come with questions for me. So if you cannot figure out how to draw those vectors, everything else better be done, and you come in with questions. All right? But this assignment goes through all these notes, and we didn't get done. So I don't expect you to get done with it all. But you should get through the stuff that we've talked about so far. Like the drawing ones, I know there's quite a few on there. Okay? And we'll finish them on Friday. I'll pause it.